Nature was never designed for consistency. Every tomato that grows under the sun carries its own chemistry, its own balance of sugar, acid, water, and flavor. Some ripen deeper, some ripen faster, some never reach perfection at all. And yet somewhere in the world, right now, millions of bottles are being opened, and every single one tastes exactly the same. Think about that for a moment. One of the most unpredictable crops on Earth transformed into a sauce so precise your tongue already knows what it will taste like before it even touches your food. That kind of consistency is not natural, it is engineered. Because if even the smallest variable slips, just a fraction more acidity, slightly less sweetness, a thinner texture, a darker shade, the flavor people trust instantly disappears. So the question is no longer how ketchup is made. The real question is, how did humans manage to control something that nature refuses to standardize? How do you take billions of completely different tomatoes and turn them into a product that never changes? What systems are powerful enough to remove randomness from nature itself? What kind of science ensures that whether a bottle is produced today, next month, or on the other side of the planet, it delivers the exact same taste? The answer lies inside a manufacturing process so precise, so calculated, that every step exists for one purpose only: perfection. This is not just food production. This is edible engineering. And today, we are going to uncover the hidden system designed to defeat natural variation, control flavor at a microscopic level, and guarantee the same unmistakable taste every single time. By the end of this video, you will understand the mechanism that makes this possible. And once you do, you will never see ketchup the same way again. This is how consistency is manufactured. Tomatoes are living systems, which means they are naturally unstable. A single change in sunlight, a slight drop in temperature, one unexpected rainfall, and the chemistry inside the fruit shifts. Sugars rise or fall, acidity fluctuates, water content changes, even color is affected. Some tomatoes mature into a deep crimson, others stop just short of perfection. From a biological perspective, variability is normal, but from a manufacturing perspective, variability is the enemy. Because a product trusted by millions cannot taste slightly different. It must taste identical every time. This is why the tomatoes used for industrial ketchup are nothing like the delicate varieties you see in grocery stores. They are bred to be stronger, fleshier, higher in natural solids, lower in excess moisture. Even their skins are engineered to survive mechanical harvesting without rupturing. These tomatoes are not grown for beauty. They are grown for predictability.
But controlling tomatoes doesn't begin inside a factory. It begins months earlier, with seeds designed to eliminate surprise.
Long before harvest season arrives, agricultural scientists are already shaping the future flavor of ketchup. Hybrid seeds are carefully selected for one mission: uniformity. These plants are designed to ripen within tight ripening windows, to resist disease, to tolerate transport, to deliver reliable sugar ranges. Even their internal structure is optimized for processing efficiency. Farmers aren't simply planting crops, they are executing a biological manufacturing contract. Fields are monitored, soil nutrients are precisely managed, irrigation is controlled to prevent dilution of flavor. Planting schedules are coordinated with factory demand. Nothing is left to chance, because randomness at the farm becomes a crisis at the factory.
But even perfectly engineered tomatoes become useless if they arrive a few hours too early or a few hours too late.
The moment a tomato is separated from the vine, the clock starts ticking. Enzymes begin breaking down cellular structure. Sugars start converting. Texture softens. Flavor slowly declines. This is why industrial tomato logistics operate with surgical precision. Harvesters move in synchronized waves. Trucks are scheduled down to the minute.
Routes are optimized. Factories prepare intake lines before shipments even arrive. Delays are unacceptable because freshness is not a preference, it is a requirement.
And once the trucks arrive, the factory has only moments to decide which tomatoes are worthy and which will be rejected forever.
As tomatoes surge into the facility, they enter one of the fastest inspection systems in modern food production. Optical scanners analyze every passing fruit, thousands per minute. Advanced sensors evaluate color spectrum, surface defects, shape irregularities, signs of mold. Even subtle imperfections, invisible to the human eye, are detected instantly. Rejected tomatoes vanish from the line without hesitation because consistency demands ruthlessness. But appearance alone cannot guarantee flavor.
Truly control taste to them, and the factory must measure something far deeper than color. It must measure sweetness itself.
Sweetness is quantified using a scale known as Brix, the measurement of dissolved sugars inside the tomato. Too low, the ketchup tastes flat. Too high, the balance collapses. So technicians continuously test incoming batches. But here is where the process becomes brilliantly mathematical. Tomatoes are blended, not randomly, but strategically. Higher sugar batches are combined with milder ones until precise targets are achieved. This is formulation, not guesswork.
But sweetness alone cannot create the flavor people recognize, because without acidity, ketchup would taste lifeless and dangerously unstable.
Acidity does more than sharpen flavor. It protects the product. Carefully controlled pH levels prevent microbial growth and extend shelf life while preserving the signature taste profile. Micro adjustments are made with astonishing precision. Fractions matter because the human tongue is more sensitive than most people realize. At this stage, viewers begin to understand something profound. Ketchup is chemically tuned.
Now the factory faces its greatest transformation yet, removing massive amounts of water without removing the flavor locked inside.
Fresh tomatoes are mostly water, but ketchup requires density. Industrial evaporators solve this paradox using vacuum technology that lowers boiling temperatures, allowing water to be removed gently without scorching delicate flavor compounds. Tons of moisture vanish every hour. What remains grows deeper, richer, more concentrated. For the first time, the texture begins resembling the sauce we know, yet something is still missing.
Because concentrate alone isn't ketchup. The signature taste still has to be built.
Now comes formulation at its most disciplined. Measured amounts of vinegar introduce brightness. Sweeteners refine balance. Salt amplifies perception. Spice extracts add complexity. Everything is metered. Everything is repeatable. There is no improvisation here, only precision. Recipes are treated like engineering blueprints.
But even perfect flavor can fail instantly if the texture is wrong by even a fraction.
Texture is not judged by sight. It is measured scientifically through rheology, the study of how substances flow. Too thick? The ketchup refuses to pour. Too thin? Consumers perceive it as cheap. So technicians test viscosity under controlled conditions. They study how gravity pulls it, how it stretches, how it settles. Yes, ketchup is engineered for movement.
And this is where the factory begins controlling something most people never think about: gravity itself.
Despite all the automation, one instrument remains irreplaceable: the human palate. Sensory panels operate in controlled tasting rooms where trained specialists compare batches against established flavor references. If deviation is detected, adjustments follow. Technology provides data. Humans confirm experience. Together, they guard consistency.
Only after passing these silent trials is ketchup finally allowed near a bottle.
Sterile containers move with mechanical rhythm. Filling systems calibrate exact volumes. Pressure is regulated.
Oxygen exposure is minimized to protect flavor stability. Caps seal freshness within seconds. Speeds are staggering, yet accuracy never wavers. But even now, one final safeguard stands between the product and the consumer.
Because before any bottle leaves the facility, the entire system verifies one thing, that the promise of sameness has been kept.
Here is the truth. Consistency is not the achievement of one machine. It is the result of layered control, seed engineering, agricultural discipline, logistical precision, optical intelligence, sugar calibration, acid tuning, water removal, flavor formulation, texture science, sensory validation. Every variable nature creates is intercepted, measured, corrected, controlled. Nature produces variation, engineering removes it, and that is the hidden mechanism. What appears simple on your table is the outcome of one of the most controlled food systems ever designed, because consistency is never an accident, it is manufactured. And now that you've seen the system behind it, you may never taste ketchup the same way again. But this is only one of the countless engineering stories hidden inside the products we use every single day. Stories most people never stop to question.
So if you enjoy uncovering the science, the machinery, and the precision behind the world's most familiar products, subscribe to the channel.
Because once you start seeing how things are truly made, you start seeing the world differently. And we'll see you in the next video with another hidden challenges that people should know about them.